Encrypting and protecting data. If that wasn't what you thought you were going to be when you came in this room, blame the schedule, not me. This is what we're going to talk about. Okay. Yeah, so I took this from a generic approach. First of all, there is a customer kind of situation we did work with to get it to work. So this does work in real life. But I also wanted you to understand kind of the reality behind the scenes. So I kind of grouped it into 3 layers. There's database encryption, column, property, attribute, whatever you want to call it, encryption, and application encryption, where you encrypt the data actually in the application, all right? Like it says there in the notes, this is kind of give you an idea of what kind of is going on from a software design perspective in general. Not necessarily that this is all in Neo4j, because, well, we'll get to that slide in a minute. But first of all, understand the difference between hashing, obfuscation, total obfuscation, and encryption. You know, if you're talking passwords, you're talking about SHA. If you're talking about encryption, that's different. And coming in the military, you learn very easily. Encryption has 3 components, and you have to protect all 3, the key, the algorithm, and the plain text or ciphertext. You do not expose any one of those 3 to anybody, okay? And that's one place where a lot of databases fail, like Oracle, for example, fails in that one. The bad news is we don't have anything internally. We'll get to why not in a minute. But we can integrate with a lot of third-party solutions out there, most of them extremely easily, oftentimes without you doing anything. For example, if you're running a cloud, you automatically have database encryption. So storage encryption, 0 effort, 0 impact, okay, really. We also can integrate with third-party APIs. In this case, for example, this presentation, working with Protegrity as application protector for property level encryption. Took an hour to do the integration. That's just because I'm a hack Java programmer, don't do it for a living, and it took me a little while, okay? Somebody in an earlier class, don't see him in here, said Mongo just released something about encryption. Do we do something similar? To really support encryption, you need a lot of infrastructure inside the database, because there's key management issues, there's data distribution issues. Like I said, though, how does Mongo support getting the data out of Mongo? Problem, right? And then you get into the separation of duties, the 2-person control or 2-person integrity around the keys especially. And then, is it certified? If you work with any of the like PCI DSS or something like that, they typically want the algorithms to be certified by FIPS. So you got to go through all the NIST testing. That takes a couple of years. So it's just a lot easier to integrate with people that already do it, and they may also exploit the hardware encryption on the CPUs to be able to do things. All right, encryption at rest. This often is the requirement of standards, all of them out there. But generally, because they address encryption from a higher level, they don't really get down to the property level so much. The intent is that people that just get access to the system can't just read the raw files and go off and hack the data. People say, well, yeah, my database scrambles it. No, it doesn't. Most databases now are open source. You can go read the source code to figure out how they scramble the data or the data structures, and you can get it pretty easily, okay? And so full database encryption can often be accomplished by external encryption, including encrypted file systems. That's the worst case, but it works, okay? Why did I say that it's oftentimes the standard? Anybody in the banking industry or take credit cards in here? Nobody. So like, chose the wrong example. You all healthcare? HIPAA. HIPAA basically talks about sensitive data has to be encrypted or obfuscated if it's exposed to public, not to partners. But really when we talk about encryption, it's stored data. And You can see they also dictate in the standard what you're allowed to store, what you're not allowed to store. So for example, that 3-digit code in the back of your MasterCard or Visa card, or the 4-digit code in the American Express card, they're not allowed to store that. So if you wondered why iTunes always asks you for that, because they can't store it, okay? Don't ask why Amazon doesn't ask you for it. Okay, now, yeah. So I worked with Protegrity, a good company, but even the experts mess up sometimes. This may be just a simple example, but for example, they have on here storing the CVV. They're not allowed to do that, okay? And then they also kind of said that employee health record is probably less of a risk than the employee name. Yeah. Anybody in here used to work for AOL? Nobody? Huh? Well, there was an incident at AOL happened where the CEO on a public earnings call with the whole world told the reason why they didn't make their earnings was because 2 complicated pregnancies ended up in neonatal intensive care, cost $1 million. And with only 2 of them, statistical inference outed them, right? Got in a lot of trouble, okay? And for the HIPAA guys, that's why the zip code has to be aggregated to 3 digits if there's less than 10,000 people in the zip code when you're exposing it, right? Okay, so how do you do it in the storage level? There's lots of ways. File system, it's the easiest, but less performant. At the device driver OS kernel layer, this is where people like Protegrity's Fuse file protector, who comes up with these names? Vormetric, IBM Guardian. They kind of operate here much faster than the file system from a encryption standpoint. And cloud storage does basically to do this anyhow by default. Or if you're running on a SAN, a lot of the SANs like EMC and so forth, they have encryption rate built into the SAN these days. So, okay. How it works from a query standpoint is that this is completely transparent to the database. We don't care. We just send the queries down through. They go through all the fun and games we do. We go to do an IO. It goes out. Somebody else messes with it. And if we have to do a read, somebody else messes with it and sends it back up the stack. Okay. And, you know, the bad news is the DBA can come in and read it if he really wanted to. We have some privileges we can protect that from that, but you know, that's kind of the bad news. If you do database encryption inside a database, this is kind of where it happens. In the stack, after the query is parsed and gets to the execution stage, as it goes to read the data from disk, if for a physical read, it'll have to do the encryption or decryption. On the way out to write, it'll do the encryption. So usually it's done at the block level or page level. It doesn't do it by the field level. So a lot of things get encrypted all at once. And it's okay, but there's some rules. Like the encryption key can't be stored with the data if you're gonna get this certified at all. You know, so there's some good things about it. Now, there's some bad things about it. Number one is a lot of times there's no centralized key management unless they interface with a hardware key manager. The encryption keys have to be encrypted as well. And that can be really fun if you take a dump from your production system and load it in QA system. It's been encrypted with a different key, and now you can't decrypt it. All the other fun and games you get into. And oh, by the way, yeah, I've done this. There's one system we worked on one time. It took about 30 days to encrypt the database. Not good, okay? Had to do something else, all right? And by the way, most sites that really do this for real, they say that if a key custodian leaves the company, you have to change the encryption key. Well, now you get to do it again, right? With the system online, yay. Doesn't work so well. So there's some problems with it. So that's why we typically tell people, do it with the driver level, with Vormetric, Guardian, Fuse file protector, cloud, or whatever. It'll be much easier for you. And the security goons that are walking around trying to do key management outside of everything else, they can integrate with that a lot better. And you don't have to worry about it, okay? All right, so proving the point. This is AWS, and if you read their thing, it says we encrypt your data anyhow. This is Google. If you read it, it says we encrypt your data anyhow. I didn't have room on the screen for Azure. They do the same thing. Encryption at rest. They do encrypt the network traffic, but they're very coy. They don't tell you where and when. So at what endpoints the encryption starts. So it doesn't likely eliminate the need for SSL between a system. So if you set up a causal cluster, you can set up SSL between the nodes. You still might have to do that, okay? But on a cloud system, you probably don't need to put a Protegrity in or anything like that. You could, but okay. Attribute level encryption or column property, whatever you want to call it. I know I'm going through this fast, started 5 minutes late, and I'm between you and lunch, and my schedule said lunch ends at 1. So don't want you to miss out. When to use it is when you have different authorized users in the system who are not authorized to see all the different data fields. Not just nodes, but fields. So like SSN, some people may not be allowed to see it. And you want to make sure that the exposure is limited to specific users. For example, credit cards, maybe only finance people can see it. Okay, do not use it for passwords. You just impose a security hole. That's what SHA is used around for. Don't do this. I worked on a healthcare system where they insisted on encrypting the names of people, and just because they thought they misinterpreted the HIPAA regulation. And it said about obfuscating names when you expose it to the public, so they thought they had encrypted names in their system. That killed searches. We'll get into why when they started looking for people that began with TAL, as a first 3 letters last name. Do not assume that people that can insert or modify sensitive data have permission to read it. Classic example, credit card. If I'm an end user buying something, I should be able to insert my credit card, but I shouldn't be able to read it back, because if somebody gets access to my account, they can read my credit card, right? So sometimes it doesn't seem like, it's common sense. Don't expose a ciphertext to people. Okay, why not? We'll get there. So where does it happen in a stack? And the query parsing normalization, we figure out the literals, we encrypt the literals, we pass them through. This is typically how you do it in a database, generically. Send it through all the way down to the disk. Some of the considerations, you're using different encryption keys for different properties. And this gets into with your relational stuff. Use different keys in different tables, or different keys in different nodes, or whatever. And kind of some decisions you have to think about. So this kind of gets into a notion of the difference between property encryption versus role-based access control or fine-grained access control. Theoretically, RBAC should be sufficient from a DBMS point of view. This is sort of true. You can grant DBAs certain roles and they cannot actually get into the database. So they can't actually get to the data with Neo4j. But that still doesn't pass a lot of people that are coming and checking your systems out, doing the audit of the systems. So generally you still maybe have to do the encryption. People don't like to also, in Neo4j you can grant permissions actually down to the property level. So you can say, Joe back there, he can read a property, Jeff can't, Dave can, okay? So we got down to that granularity, but that kind of makes it hard for app developers because they have to develop apps based on what data people can see and not see, so they don't like to do that. So encryption kind of makes that easier. They can develop one level of the application. Okay, and RBAC, data is only encrypted on disk. If you did the disk encryption, still on encrypted memory. So if you're worried about people doing, looking at mem dumps and stuff like that, it doesn't do it. So property encryption does solve this issue. Okay. So yeah, encryption by itself is not sufficient. There's a lot of protection. So that means you got to separate DBA and SSO. You also have to separate who has keys. And in some places, they want dual key control. They don't have one person have the secrets of the kingdom. So it gets quite involved. Now you know why we don't do it internally. Here's what I was talking about earlier with exposing ciphertext. So the answer's on the screen because it's pretty obvious. Who's colorblind? Standard statistical attack. You know, there's only two different. You don't think that could happen in real life? Been there, done that. Okay. There's a state of court appellate court system. I won't say what state, but they wanted each judge's vote kept secret. Now we all know why. But the other thing was judges were assigned to write the opinion for the majority or minority, irrespective of how they're voting. So I don't know if that's true about the Supreme Court or not, but in this court system it was, okay? So they used a .NET encryption plugin, and yeah, the day it went live, one of the court clerks broke it. Figured out how everybody was voting. Because of low cardinality and exposed the ciphertext, and away she went. She knew it all, okay? So that's why there's this notion of having initialization vector, some people call it SALT, to scramble the low cardinality data. And there's also why you should implement something called decrypt permission, which says that you have to have permission to decrypt it, not just insert the data, but also decrypt it. And if you don't have permission to decrypt it, you just get a totally obfuscated, masked output back. All right. So here's how initialization vector works. You take the same data, plug it in, and you get the different ciphertext out. Okay. Why did I point that out? Is because if you're really down the weeds from your talking to your DBAs, they're all worried about storage size. It does increase the storage. These days disks are cheap, right? So we don't care anymore. They might. Where you do care, I get this complaint a lot of times. When you're encrypting properties, what happens? Let's see. Yeah, if you run the first query, find Crowther, ding, 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 pow. Traverse the index, find him. He's not in a room, I can pick on him. All right. Find everybody who starts with M. Pretty easy with a B tree. You go to the first node, do a leaf scan down through, find all the M's. When it hits an end, you stop, right? Pretty easy from query optimization. Find something that ends with MAN. Well, usually that means a leaf scan of all the index nodes and then following everything that ends with that, okay? It's a little more. All right, that's standard. Now let's do it encrypted with no initialization vector, okay? So, we go find Crowther. Now the index is sorted by the ciphertext, which is not lexicographical order. So we used to be up at the top, Crowther's now way down there, but is ciphertext all the way, because we encrypt the ciphertext from literal, we get there. What happens begins with M. M just became who knows what in ciphertext. You're scanning the whole stupid index, decrypting every value to find it. The optimizer or query planner is probably gonna pick something else, okay? And this gets back to the example of the customer I talked about that was trying to encrypt their data for last names, and their front-end users complain about query performance. Bingo, that's why, okay? We got a couple of million or tens of millions of customers, it takes a long time. Now the ends with MAN, still the same problem, okay? There's other issues. We'll get to those in a second. But what happens if you use an initialization vector? That means that the same word encrypted is, unless you use the same exact initialization vector, it's going to be encrypted differently every time. And the initialization vector is typically in the hashing of the encrypted value, so you don't know it when you do the query. So once you encrypt it with an initialization vector, it all becomes scan everything, and decrypt. Okay, so that's why they tell you on high cardinality data, don't use an initialization vector. You can never index it. All right. All right. So people say, okay, that's fine. Standard B tree, we have those. What about if you have bitwise indexing? We don't have that. But the answer is once you start doing encryption, you change the ciphertext, probably different values that you thought were the same don't end up the same. Bitwise indexing kind of fails at that point. Same thing with skip indexes. So, once you start encrypting data, things start changing rapidly. Okay. This is a big one. Besides the indexing, queries can be very impacted negatively if you start doing property level encryption. So, besides the range scan index is not working, order by. Right? A common optimizer technique, if it sees an order by, it uses the index to short circuit the sorting. And it makes it a lot faster. Can't do that no more. We got to actually get the values back and then do the sorting. Okay? Indexing low cardinality data, now you can't use any sort of indexing at all. Okay? Now, low cardinality data and Neo4j, we can cheat. You just make it a label, right? And plus it becomes an index. Okay? Otherwise, like I say here, it takes a lot of engineering effort and features to implement. Another good news is DBAs can't see the data, and the bad is we don't support it directly, but you can do it with Protegrity, and this is where we did it. Okay, so you can. The good news about this is you can move the data from the source system. In this case, the source system was Oracle. They didn't use Oracle's transparent data encryption, they call it TD, and they used Protegrity instead. That meant we could take the encrypted ciphertext from Oracle, still was encrypted, and put it in Neo4j without decrypting it and passing it in the clear, which is a security hole. Okay, that's the other reason why, like I mentioned with distributed data, using a third-party API, that's kind of a standard. And this is, for the one company, this was their corporate standard to use this. Okay, and all their algorithms are certified, and they had all sorts of different algorithms for different things. So it really worked really well. This is kind of how it worked. The query processing, we put a wrapper, we use the UDF around their Java API. The query processing just called the UDF. It came in and went through the application protector. It actually cached the keys and the rules locally on the database instance. So we didn't have to go across the network. The overhead was like microseconds for the input. I think it slowed down a load CSV marginally. It went from like 1 second to 4 seconds to load the data. So not very much. I mean, it sounds like a lot, but in reality it wasn't for the number of properties we're encrypting. I'm not going to go through this too much other than, here's the cipher before if you're doing a load. And here's the cipher afterwards with the phone number is tokenized, the taxpayer identity is encrypted. The tokenization just kept the same format. So it was like a number, dash, number, dash, number. So it looked like a phone number, but it wasn't a real phone number. So somebody tried calling it, spammer, right? But the taxpayer ID actually was encrypted. So it was gobbledygook, okay? And could you do it yourself? Absolutely, there's Java functions out there for encryption. I did it years ago, but then you gotta get it certified. Now it's actually an interesting exercise because you can do it and do some sort of stupid SHA hashing plus something else. And that way you can export production data from your production systems, put it in dev test QA, and it maintains all the cardinality and so forth that you can test with, and nobody knows the data because if it's SHA, one-way hashing, they can't get to it. Plus if you hash it beforehand. Some people like to do it in the application layer. We had a couple people try this where they actually, one person was actually using the open source Neo4j libraries to get the parse tree to figure out where the literals were so he could parse the literals before he sent the query over to Neo4j. Kind of an interesting, long engineering problem. The problem with that is it limited which cipher he could use. And this really has big, huge problems on performance because like in the SQL area a lot, you're joining on the primary key, and the primary key for like people's oftentimes is the social security number, and a lot of times using different keys, you have to do the joins back in the application. Just gets really ugly, and don't do this. So, kind of the way to do it, if you're kind of worried about data protection at rest, look in the cloud or the driver level for the solution. Sensitive data, different user. This is where you're going to create with third-party API like Protegrity. There's other ones out there. Network in transit protection, SSL. That's a common standard. The red there just means the data encryption doesn't really handle it, but you can do it with SSL. Backups, yeah.
How would you recommend we do it in, for example, when it comes something in Aura DB?
Aura's in the cloud. We also make sure the storage is encrypted on the cloud.
Sure, but you have a PII field, SSL.
Yeah. So integrating with a third party in Aura might be a little fun. Something we've been after the Aura folks for years has been the ability to allow customers create store procedures or user-defined functions and deploy it to the cloud. It's been difficult getting that through because, like we talk about SOC 1 and SOC 2 compliance, the one thing you don't want is people having access to the file system, because then they can do nasty things, right? And if you allow somebody to create a store procedure, our API has no restrictions on what you can do. You can write to a file. Look at APOC, right? APOC.export. You export to a file. You can read a file. They can do all sorts of things. So right now, Aura doesn't support UDFs or store procedures. So that might be a one-off where you'd have to talk with, if you really need it. So I said it was a general case. If you really need it, you'd have to talk through your sales rep and bring in the cloud product manager. And there's probably an exclusion process they can look at. But they'd probably need the source code and a bunch of other things.
Yeah, so I think by the end of the year, you're going to have SOC 2.5.
Yeah.
Is that cool?
Yeah.
Is that hot?
Because SOC 2 requires 6 months of SOC 1 beforehand. So.
Okay, but is that it? It doesn't allow for encryption and stuff?
Well, property level or attribute level encryption is not part of SOC at all. Storage encryption is there, but we've always had that, right? When you look at a cloud, there are cloud managed keys they do automatically. If you look at your storage when you pick the disk, it'll say, do you want a AWS managed key or a corporate key? Okay. So we had to do some stuff there to make sure we could kind of control the keys, so forth. But yeah.
So at the moment, if you want to encrypt at attribute level in Aura.
In Aura, it's already encrypted on disk.
Sure,
But if you need to encrypt the property, then you probably need to talk to the Aura product manager, and they're going to want to see the source code. They're going to know all the reasons why, because it's now an exception stuff. And here's the real issue with it. They can look at the source code, and they can see, yeah, everything's fine. But remember, Aura, we're automatically doing the database upgrades for you. So you're going from 4.x to 5.x. If the API changes, it breaks, right? So they have to look at that and consider, from a one-off, do they want to manage it or not, so forth. So, like I said, that's a one-off discussion you'd have to have with the Aura folks. It's not something generally we're going to support generically for everybody. And I'm not even saying they'll support it as a one-off. I just know anything special you have to do one-off exceptions for. We've had customers come in, they want more memory than we can give an Aura. And through one-off, sometimes they can get it. Okay. The big one to me is performance impact. Storage encryption obviously has the least performance impact. Property level encryption, obviously, like I said, certain queries with indexing, going to be an issue. With application level, it's going to be even worse. Okay. And like I said, database encryption or storage encryption, 95% of the time it's going to solve your problem. You might have the one case there, whatever your name is, gentlemen, Jay. You may have the one case that's in the 5%. That's valid, okay? But just make sure you're really in that 5% case. If somebody told you this is what's required because some regulation says that, go get a copy of the regulation, because oftentimes they didn't read it themselves.
I'm in financial services, so that's definitely.
I used to work a lot with the banks and trading systems, okay? So, is it MiFID 2 you're using?
Again?
MiFID 2?
No, I don't know what that is. But
It's one of the security standards for,
so in Snowflake, we encrypt some attributes in Snowflake.
yeah.
Yeah, I did.
Yeah, yeah. So, again, like I said, most of the industry standards, like PCI DSS is around payment cards, right? Payment card industry. So a lot of banks get into that. And that one, if you notice, it actually spells out storage, encrypting at rest. So I'm not saying that because we don't support it. I'm saying that because your application may suffer if you do it needlessly, okay? And then you get a lot of unhappy users. That's probably more important. Okay, I got 10 minutes. So, when you can use storage encryption, you can complement it with role-based access controls. And if you gotta use property level encryption, third-party API. I know it works with Protegrity. I thought I had the source code in here, but if you really want it, I can send it to you. It's real simple.
So, you can do it with third party
Yeah, like I said, we did it with Protegrity.
in Aura.
Well, not Aura, sorry. No, not Aura. On, you're in a bank that let you put it in the cloud. Okay, so a lot of banks are doing cloud now. Okay, yeah, all right. Most of the banks I work with, they weren't putting anything in the cloud for a long time.
Oh,
Yeah. Yeah. Data centers got expensive. Yeah, okay. And use SSL for in transit. Typically that means disabling the HTTP port. Now some standards, for example, you talked about HIPAA. HIPAA allows you to not need SSL if you're on the local host. So that's one of the things where sometimes you really got to read the standard. If somebody argues with you, you can show them where the standard actually says, no, this is the way it's supposed to be. Okay. All right, 8 minutes for questions.